Gravitational technologies harness nascent energy from the material vacuum, spacetime, and otherwise manipulate it, inducing gravitation. This gravitational manipulation translates into the manipulation of the spacetime metric, the localized measure of perhaps globally curved distances and angles in the physical vacuum. But what exactly is spacetime? The most profound realization of higher dimensional physics is that time, like consciousness, is an illusion. It is just another dimension of space, exactly like the three you can see, in some higher dimensional space that our perception of time proves that we exist in. Let's take a look at higher dimensions from the point of view of geometry. Recall that algebraically, geometry is just the solution of algebraic equations. Then all we really want to do is add a fourth axis to our Cartesian graphs and see how far that modest mathematical assumption will take us. Now, extend a point in one direction to make a line. Extend the line in another direction to make a square. Extend the square in a third direction to make a cube. Extend the cube in a new fourth direction to make a hypercube. To grab the cube and pull it into or out of itself in 3 space is equivalent to a projection into 3 space of the 4-dimensional hypercube. Add a point to another point and connect them to form a line in 1 dimension. Connect another point to the others to form a triangle, a polygon, in 2 dimensions. Connect another point to all the others to form a tetrahedron, a polyhedron, in 3 dimensions. And then connect another to form the simplex, a polytope, the 4-dimensional analog of polygons and polyhedra. The triangle has 1 face, 3 edges, and 3 vertices. The tetrahedron has 1 solid, 4 faces, 6 edges, and 4 vertices. If every triple of vertices constitutes a face, then the simplex has 10 triangular faces. Similarly, if every quadruple of vertices constitutes a solid tetrahedron, then the simplex has 5 solid tetrahedron faces. In the same manner, a tetrahedron has 1 solid component to its edges, vertices, and faces. The simplex has 1 4-dimensional polytope solid that lives outside of 3 space, not unlike how a cube lives mostly outside of 2 space. And just like passing the cube through the plane shows slices of the cube in 2 dimensions, a simplex, hypercube, or other polytope can be passed through 3 dimensions to show 3-dimensional slices of their 4-dimensional geometry. The impossible ways the edges crisscross over themselves in this projection is not unlike the way a shadow projects in 3 dimensions. The intersection of these polytopes with 3 space is very similar to the intersection of their 3-dimensional analogs with 2 space. Sections of a cube are squares, and in 2 dimensions, a square suddenly appearing and disappearing would be an indication of a cube that just passed through 2 space. Sections of a hypercube are cubes, so for a cube to suddenly appear and disappear in 3 space is an indication that a hypercube has just passed through our space.